In this paper, we study the problem of supporting effective and scalable visualization for the rapidly increasing urban data. Different from existing methods, such as nanocubes and hash cubes, which mainly support heat maps and bin plots, our proposed ConcaveCubes supports cluster maps on large-scale geographic multidimensional data. We first cluster geographical data points that are close in distance and share similar features, and then represent each cluster on top of the map. We demonstrate our system based on Australians' real estate data. Here, in our map view, we provide two kinds of cluster maps. In the bubble-based cluster maps, each bubble represents a cluster of properties. Color represents the average price, and size represents the total number of properties in the cluster. To more precisely represent the geographic information of each cluster, we design boundary-based cluster maps. Here, each cluster is represented by a concave polygon. How to generate an appropriate polygon for each cluster is one of our technique contribution, which is described in section 4 of the paper. After the user selects a cluster in the map view, a linked multidimensional view will be shown to the user. In the multidimensional view, we present how the properties in the selected cluster differ from other properties based on user-defined dimension measures. For each dimension measure, a histogram summarizes the information of the selected cluster, and a joined line chart presents the global information. For example, here I selected 8 measures, including house price, distance to the nearest hospital, and so on. Then when I select a cluster in the suburb of Brighton, 8 histograms plus line charts will be drawn here. The first dimension is price, and the histogram visualizes the price distribution of this selected cluster, while the line chart presents the price distribution of the whole state. We can see that house prices in this area are much higher comparing to the whole state. We might discover the reason from other dimension measures, as people in this area have a high income, and properties in this area are close to train stations, supermarkets, and have a decent distance to the city. Our proposed ConcaveCubes is a hierarchical data cube structure that pre-computes clusters to support the designed cluster maps and different user interactions. A different type of user interaction corresponds to a different level at ConcaveCubes, and the key idea is to reuse existing calculations and visualizations to support user interactions. For example, panning and zooming directly influence the map window, and the change of map window corresponds to the level of geographic semantics in ConcaveCubes. After users apply zooming or panning, we calculate a set subtraction between the current and previous map windows, and then partially refresh the visualization based on the subtraction result. Zooming in or out will also change the granularities. For example, here, if we continue to zoom into a finer granularity, the cluster in Brighton will break into several smaller clusters. We can see that those properties near the coastline are more expensive than those that are not. To better illustrate the idea, we also provide a function to change the granularities while staying at the same zoom level. Changing to finer granularities, we can see that some large clusters might break into multiple smaller clusters. For filtering, it would affect the level of categorical dimensions, and only those new added or deleted clusters will be affected on the map view. Thanks for you watching.